Hello everyone, I am Sneha Rai and this is my project presentation for my internship in immersive information technology. As my embedded system project, we had to perform simulation of washing machine using PIC microcontroller using picsimlab. So, with the recent trends in technology, the scope for innovation is always possible. So, just for an example, our daily household appliances have now converted to smart appliances, and this has become possible with interaction of hardware with the softwares using embedded systems. But what is the specification or what is the thing that makes embedded systems special? So, for embedded systems, generally C language is used. C language has a part extension of C language is embedded C language, which is specifically designed for programming microcontrollers and works on various platforms. But basically, as general purpose programming languages, initially we start with C languages, which is compatible for desktop systems like Windows, Linux, and Mac. It is used for various applications, while embedded C is a specific dialect of C for programming microcontrollers. It runs without OS and directly on hardware and mainly focused on hardware control and real-time performances. Embedded system is used for microcontrollers like 8051, PIC, ARM, STM32, and it has better library extensions available. In C languages, it has standard libraries that are full-featured, input-output memories, and file handling. And so it is useful for purposes such as system software, kernel development, file handling, and user-friendly language. And this coding, this is done with MPLab, which is a free software which helps to write, build, and upload code to pick microcontroller in our case. So, what is embedded systems? Embedded systems is basically a specialized computer designed to perform dedicated tasks or functions within a larger system. They are typically embedded in hardware and optimized for real-time performance, efficiency, and reliability. It has many applications in medical field, automotive systems that require real-time responses. Embedded system here ensures that the system reacts in milliseconds or even microseconds. Devices like smartwatches, pacemakers, sensors must run on low power, and so it is optimized for energy efficient operation, perfect for portable and wearable technology. So, now what are the types of embedded systems? Embedded systems are divided based on the requirement of functionality and performance and based on the ability of the microcontrollers. So it is divided based on requirement and functionalities as real-time, standalone, mobile, network. Standalone, these embedded systems takes decisions on their own and don't require a host computer to operate. So you don't have to be available every time to make this work, such as Tesla cars or your calculators. After you give them an instruction or instruction to operate, it performs on its own. And next, real-time embedded systems. Real-time, as it suggests, within the time and often within a deadline. So these embedded systems are used for technologies like missile systems, airbag deployment, anti-lock braking system, anti-lock brake systems, so that major injuries can be prevented as the task is performed within the deadline. Next, mobile embedded system. It is present in your daily devices which you can carry from one place to another. For example, your smartphones, fitness trackers, laptops, smartwatches. Network embedded systems, it allows connections from other devices and transmits and receives data. For example, your home security systems. When you're not present in your home, but you still get the data, and you can receive the data with fast and often in real time. Let's come to our project, simulation of washing machine using PIC microcontroller in picsimlab. For this, we have used the tools MPLAB IDE, XE8 compiler, and picsimlab. MPLAB is a software made by Microchip, used to write, configure, and debug code for various microcontrollers. It helps you build the code and upload the code to pick microcontrollers. Here we have its features are that we can write code in C language or assembly language, simulate the code, and compile it using XE8 compilers, that is for 8-bit pick, and that is compatible with Windows and Linux. And what we need here is just writing the code, building it, and uploading it to the chip. Next, to simulate this, we have used picsimlab, which is a virtual lab simulator for PIC microcontrollers. We can test our embedded code on virtual hardwares like buttons, LEDs, LCDs without building a real circuit. There is no need for breadboards or wires or microcontroller. It connects with MPLAB X IDE and simulates the real circuit. So here we have a virtual microcontroller from which we can click the buttons and switches and see the LEDs blink or LCDs displays text and test our code before trying it on the hardware. So the requirements of washing machine here, we have decided to use PIC microcontroller, PIC16F877A, tactile switches, LCD display, timers, interrupts, buzzer, and fan. This washing machine will perform as follows. As using the microcontroller, we have decided switch 5 for powering on the screen, switch 6 for pause or stop the function of washing machine in between, switch 4 for navigation or scrolling, and switch 1 for checking the door status if it's open or closed. So this project is supposed to perform this and display its output on CLCD, display the washing status, water level menu, and then buzzer and motor for alarm and performing the function. So, PIC microcontroller. PIC microcontroller is a peripheral interface microcontroller developed in 1993 by General Instruments Microcontroller and Microchip. So, as we need an embedded system to work on low power operation, its operating voltage just requires 2 volt to 5.5 volts. It has a high performance RISC CPU and flash memory up to 8K, RAM up to 368 bytes, EEPROM 256 bytes, and a 20 megahertz crystal oscillator operation, 33 input-output pins, 8-channel 10-bit analog to digital converter, 2 PWM power pulse width modulation channels into 8-bit counters and one 16-bit timer or counter. It has one port for USART, one port for MSSP, one port for SPI, that is Serial Peripheral Interface, one port for I2C port. These are the communication protocols that this microcontroller supports, and this microcontroller is a low voltage programming and low power consumption microcontroller and a user friendly microcontroller for a beginner in embedded projects. Next, we have tactile switches, that is, a tap switch or a push button that indicates any physical bump or a click as a signal that the circuit is closed and sends the signal. In our microcontroller, we have used it to take user input and help the user to scroll down the menu and select for various menus and applications. Here, as we can see, uh, RB0, RB1, RB2, RB3, RB4, RB5 are the 6 switches that are present. Also, RB0, that is switch 1 that we have kept for checking the door status in the event that is on. It means the door is open and the user needs to close it. RB3, that is switch 4, here is used for scrolling the menu, that is water level display or the type of washing function. Using this, Here we have two types of presses, long press or short press. Using the long press, the user can select the particular option, and with short press, the user can navigate or scroll the menu. It works on level triggering or edge triggering as with used in clocks or flip-flops. Level triggering or edge triggering here defines whether it is a long press. Here we have decided if there is a long press for a particular seconds, then it will be considered as a long press that will help the user to select that particular option. And if it's just there for a momentary pause, then it is a short press that will help to scroll the menu. Switch 5 here, that is RB4, is used to power on the machine and start. That is starting the machine and starting the process of washing. RB5 is switch 6 that is used for stopping or pausing the machine in between the washing. So next we have CLCD display, crystal liquid display. The CLCD or dot matrix crystal liquid display is used to display the output and show the user the interface. Here in our project, it has been used to show the various menu of selection such as washing type menu in which we included several options such as delicate, heavy, dry, aqua wash, whites, eco cottons, and so on. Next, we made water level menu, which included auto, low, medium, high, and max to judge the water level with different codes. Next, we use the CLCD to display the timer to show how much time it takes for washing, rinse, and spin. So it shows and displays the warnings as well as the instructions to the user for different switches, such as which switch to press to start, which switch to press to pause. It shows the function that is currently being going on, and when the program finishes, it also displays to take out the clothes. And warnings such as when the door is open, so it asks the user to close it. Next, we have timers and interrupts. Timers in embedded systems are crucial for measuring time intervals, counting events, and generating delays. They consist of a counter that increments or decrements based on a clock signal. Some timers are designed to keep track of the system time. In our microcontroller, TEC16F8778, there are three timers for PWM generation. PWM means pulse switch modulation generation. So there are three timers, timer 0, timer 1, and timer 2. Timer 0 and timer 2 are 8-bit timers and timer 1 is a 16-bit timer. In our project, it has been used to count the time for washing, rinse, and spin of the clothes in washing machine. Now, when the timer reaches its maximum values, it goes back to the initial value, and that generates an overflow. Now, when an overflow is detected, it is considered as an interrupt, and then it goes to ISR, that is, interrupt service routine. After that interrupt has been resolved, it goes back to its initial value and the timer starts again. Here we have used timers to keep track of the washing of the clothes. Next, we have fan and buzzer. Now, the fan here is to maintain the temperature of the system and connect it via a motor. Now, to show that the system is working, you can see the fan. It will be working when the switch turns on and it maintains the temperature of the system via cooling. Now, whereas the buzzer is an alarm to alert the user to keep a track of washing machine and alert the user when the clothes are washed. Now, to know if the clothes are washed, it buzzes and alert the user that the program is finished and the user can take out the clothes. Now, in the event if the washing machine gate is open or switch 1 is pressed. Here we have mentioned RD0, that is switch 1 to press it to open the gate. So if in case that switch is pressed, that means the gate is open, so it allows the user to close the gate. And during that, the cooler it turns off, the fan it turns off, and the buzzer keeps ringing until the user closes the gate. And then the fan again starts and the buzzer stops. Now let's take a look at our project demo. So here you can see NPLab IDE, where we have written the entire code for this simulation of replicating a washing machine. So you can see this is washing machine function definition file, and we have here used C language, and we have used loops, assigned variables, and you can see there are different washing programs I mentioned, water level mentioned. We have written for washing program display. We have used macros in header files to define the port and assign value to them, and source file to mention the working, how we want it to work, CLCD right. In header files, we can see there are several files. In source files, there are several files. ISR, that is interrupt service routine. We have mentioned one interrupt file, one file for digital keypad that was tactile switches, then for timers, for timer on and timer off. Now we have created a main.h file so that, and you can see we have written several files so that we don't have to write in every file. We can include the main.h file in every file instead of writing the whole set of include for every file. In this, we have mentioned for different switches digital keypad.h. Now we can build the project. You can see in the output terminal it shows build successful. Now to locate this file, it is in hex format. So below this we can see the extension production.hex. So that is our hex file that we will now run in picsimlab. In picsimlab, this is PicGenius board and our PIC168778 microcontroller. Make sure you choose the correct board and correct microcontroller. And now we can load our file and start it. Now we can see the watching program menu displayed. Short press to scroll through these 12 options: bed sheets, rinse dry, dry only, wash only, aqua, and then a long press to select any particular option. Here we are choosing, for example, delegates. After a long press, we can see water level menu. It has 5 options: auto, low, medium, high, and max. And similarly, long press to select the option, short press to scroll. Now switch 5 to start the process. Here we can see timer has been started. The fan is turned on. Switch 6 turns it off. The fan is off now. Switch 5, it again turns on. Now what if we press switch 1? It's set to close the door that is open by the buzzer alarm. And now we can see the function has gotten from wash to rinse and now spin. Now again, we know the program is completed, so the buzzer stated the program is finished and the clothes have been washed. Now the project, to conclude this project, we have learned many things. So we can start by C language, embedded C, embedded systems, brief idea about the microcontrollers, concepts about software. So C language. Here we learn about how different data types are assigned and how different variables are assigned and how loops are used. Here we have used for loop, if else loop, all this we have used by learning C language. Next, we learn why embedded systems is necessary and how we can use it. What are its types, like standalone, real time, networking, hybrid, based on its requirement. And next, we use one microcontroller, PIC microcontroller, PIC 16F877A. We got idea about how many RAM it has, how many timers it contains, on what frequency it is operated through its datasheet, and we learned several concepts of edge triggering, level triggering. We learned about basics of many circuits. We learned about what are sourcing circuits, syncing circuits, what are timers, how many timers we have, why it is necessary. We learned about interrupts, how interrupts are generated and how we can handle it and how interrupt service routine works. Next, we learned about the component descriptions, various components we used here. That was the microcontroller, tactile switches, LCD, fan, buzzer. And next but not the least, we learned a new software here, MPLab ID software, to write this code and debug it and build it and simulate it using picsimlab. Picsimlab here worked as a simulation platform in which we simulated our entire project and completed it successfully. Thank you.